Hey guys and girls, this lab is really, going to have a lot of practice on drawing Lewis dot structures and in determining the shape that goes along with it, along with whether or not it's polar or non-polar. These are questions you can expect to see on your test next week. So, make sure you're really working out hard, stay focused. You also definitely want to build the models. After you build the model, you want to make sure you've got it in your hand, can kind of see it by holding it versus just see it by looking at it. Obviously, the purpose of this lab is to be better at drawing molecules, predict the shape of those molecules, and then build the structure. Directions are pretty self-explanatory. On a separate scrap piece of paper, which will be turned in, so clearly labeled, try to work out the Lewis dot diagram. Once you've got the right Lewis dot diagram, then transfer it to the chart on the next page. Determine the number of directions of non-bonding and bonding for the central atom. You can ignore all the ligands, just the central atom. You still need to show the dots on the ligands, just like we talked about in the notes, but you don't need to worry about how many electrons are out there in terms of this question. Bonding, non-bonding electrons. 15 possible geometries. Let's look at them. You've got them right there. Linear, 2 directions, no extra pairs. Bent, 2 directions, 2 pairs, or 1. I'm going to try to draw. Here we go. So, 2 directions, right? 1, 2. Bent is usually 2 directions. And the other direction is either 1 non-bond or 2. And I will try to use the red line to represent the non-bonding pair. Let's see, our tetrahedral, which you already know, is 4. Back to purple. 1, 2, 3, 4. And then you go trigonal pyramid, and you replace one of those with red. Trigonal bipyramid, this is a fun one. You have 1 up, 1 down, and then you have the little triangle around the middle. Seesaw is one of these, but it's 4 in 1. So 4 directions and 1 that's switched over. T-shaped is 3 and 1, 3 and 2, or these 2 are gone. Linear is 2 and 3. Get rid of the 3 spokes around the middle and replace them with just electrons. And then you have your octahedrals. Definitely want to build these, build them correctly. Look at the shapes. When you've got them built, you can usually figure out if they're polar or not. So let's see, octahedral is 1, 2, 3, 4, back in time, forward in space. If, however, instead of octahedral, which is 6 and 0, if it was 5 and 1, here we go, 1, 2, 3, 4 balance, but the front and the back don't balance. It'd be polar. A lot of times we look at whether or not there is symmetry in the way it's built, and then in the elements on the outside are all identical. So how are we filling in this chart? We are drawing our best possible Lewis dot diagram onto here. Your good handwriting. I'm looking at a couple of the guys over there in the corner. Yep, you. With the red shirt on. Draw your best Lewis dot diagram there. Work out the scrap on a piece of paper that is separate. The next column, number of bonding pairs versus unshared pairs. So it's all about the central atom. Does the beryllium have 2 that are bonded and 1 that's not? What about this boron? That's what goes in those 2 spots. And then electron region geometry versus molecular geometry. So let's go back a page, and I will explain that. Like a bunch of these, we'll talk about like the octahedrals. These guys here, octahedral, square pyramid, square planar, T-shaped, linear, they're all 3 and 3 is 6, 4 and 2 is 6, 5 and 1 is 6, 6 and 0 and 6. All of these are all in the same electron region geometry. They're all, let's say, 6 in total. But the molecular geometry might be 5 and 1. And if it was 5 and 1, then it would be square pyramid. Yep, square pyramid's 5 and 1. but those are all in the octahedral family because the 5 and 1 is a total of 6, 4 and 2 is a total of 6, 3 and 3 is a total of 6, 2 and 4 is a total of 6. So all of those are octahedral when it comes to electron domain geometry, electron region geometry. Molecular geometry is the more specific. So that's usually people say that the electron region geometry is the vague one that kind of encompasses several different names, where the molecular geometry is just the bonds. It's the more specific name that tells you what's going on with the bonds. So to compare it to the ones you already know again, you already know, so you know tetrahedral versus trigonal pyramid pretty well. Tetrahedral is 4 directions. Trigonal pyramid's also 4 directions, but it's 3 bonds, 1 extra pair. So both of those fall in the tetrahedral family of 4 directions. And then dipole moment, you have to see if it's got an unshared pair or something like that going on. Yes, there are post-lab questions. You need to answer them carefully. I think they're all pretty self-explanatory. And analysis. Yes. Yes, yes, yes. Lab report? Question mark? Yes. Lab report. You're still doing a standard lab report. Name, purpose, procedure. Data is a little sketchy. I'm not sure. Oh, I know. Your data is all of these charts. Sorry. Your data is all of these charts. I'm not asking for many things in terms of observations. No graphs, just the charts. You have those questions to answer. Excuse me. In your analysis, it's really about how you understood it. A lot of people have a vague understanding right now. Hopefully after building a dozen of these things, you'll be stronger. Some of the drawings are a little harder, like this one here, C2H2F2. There's 2 carbons in the middle, so you name the geometry for the one carbon, you name the geometry for the other. You also end up having, 2 answers here, because maybe the electron domain geometry is different for the 2. What else could I say about this? Look at your Lewis dot structure and pick the model piece that fits with that. If you, on your Lewis dot structure, you have bonds in 4 directions and 1 extra pair, that's 4 and 1. You need the model piece that can do 5 directions. If you have a Lewis dot structure that goes in 3 directions with no extra pair, you need the one that does trigonoplanar, the one that goes in just 3 directions and it's flat. So you have to be careful when you build them so that you can think it through pretty clearly. I can't think of anything else. You just need to take your time and build them. These 2 here, this is on the second or third page. You have CH3OCH3 versus CH3CH2OH. That's the same number of carbons, but the oxygen's in a different spot. Those are called isomers. They have the exact same formula, just the pieces are rearranged in order, which changes some of the properties of it. This one's going to have several answers. You're going to have what's the carbon on the left's perspective for these 2 and this, oxygen, carbon on the right, carbon on the left, central, oxygen. But for polarity, that's one answer. One answer is the molecule polar, is the molecule nonpolar. Once you build it, you might be surprised. What it looks like here and on paper here might not be what it looks like when you build it in your hands. I'm trying to find, this one has a double bond in it. When you're working with double bonds and the model kits, that's still one direction. So maybe you just put the bond in there backwards or something like that, something that you can kind of recognize that that bond is different than the others. There's different color bonds you can use, lots of options, but there are some double bonds in there, so you want to represent those some way on the model, but you can't stick two bonds from the element, the ligand, from the oxygen to the sulfur on the model kit. It's limited. It can only have one direction at a time. So do your best. Like if something's going in 3 directions, even though there's double bonds in there, use the one that goes in 3 directions. Alright, I think I've thoroughly confused the situation. Practice, practice, practice. If this is not enough practice for you, open your textbook and find a whole fantastic world of other ones. You've got all 15 names down here. I know linear, bent appears, it's really 2, but you look at this, it's 1, 2, 3, 4, 5, 6, it's like 15 different options, and you need to get to know all 15 of them today before the test. So practice. Alright, there you go. Bye-bye.